Good morning, students, and welcome to 10C. The unit which we want to discuss today in physics is waves. What we are going to learn in this unit, the contents of this units are describing wave motion, the terms involved in waves, and the behavior of waves. The learning outcomes are that describe what is meant by wave motion as illustrated by vibrations in ropes and springs and by experiments using a ripple tank. State what is meant by the term wavefront. Define the term speed, frequency, wavelength and amplitude, and recall and use the formula of velocity is equal to frequency into wavelength. We will define these terms all together. Describe transverse and longitudinal waves in such a way as to illustrate the difference between them. Next is describe the use of ripple tank to show reflection at a plane surface, refraction due to change of speed at constant frequency. Describe simple experiments to show the reflection of sound waves. So let's begin our topic from the definition of waves. What is mean by waves? Waves is nothing but a traveling disturbance. It's a periodic disturbance of the particles of the substance which travels away from source. It means that suppose that if you throw stone in a quiet pond of water, you will observe that circular ripples are formed and they move away to the edges of the pond. So what you have caused by throwing stone into the pond of water, you have imparted energy to the particles of the water, and the water you will call medium, so the particles of the medium, and the energy received by the particles, they do not keep it with you with themselves, and what they do, they pass it to next particle and next particle and next particle. In this way the energy is traveled or propagated or transferred from particle to particle. The particles during this process, they do not move with the energy, they just transfer the energy from one point to another. So you can say that a periodic disturbance of the particle of a substance which travels away from source. What is meant by the word periodic? Periodic means it's like vibration or motion which repeats itself after regular intervals of time. Like suppose that you go out of your room and you come back in 5 seconds, and each time you go out and come back in 5 seconds, in 5 seconds. So your going out and come back is what? That is periodic. Our earth rotates about the sun and the motion is periodic. Similarly, the moon rotates about the earth, that is what? Periodically it does it. Similarly, disturbance caused by vibrating body which travels due to periodic motion of particles without net movement of particles, means the particles will vibrate, but during the vibration they do not leave their sides, they just vibrate on their sides and they pass energy to the next particle. Waves are also called energy carriers. Why? Because they carry energy from one place to another. So this was the definition of waves. Simply you can say waves are energy carriers, or they are periodic disturbance which travels away from its source with the help of particles of medium. Now next is the types of waves. There are different types of waves. It depends on the mood of the waves definition. For example, here we are going to define two types of waves. One is known as transverse waves and the second is known as longitudinal waves, and I'm going to define these on the basis of the behavior of the particles of the medium. They during the transmission of energy, how the particles behave. So the transverse waves, it's a type of waves in which particles of the medium vibrate perpendicular to the wave motion. They are called transverse waves. Like for instance, let me take a pen. So the transverse waves are these are the type of waves in which particles of the medium vibrate perpendicular to wave motion. They are called transverse waves. Examples are water waves, light waves, waves set up in a rope. For example, if I want to sketch the figure of such waves. Suppose that here's a wall, and what you do here is a hook, for example. With the hook you tie a rope, for example, and then you wiggle it up and down. What will happen? A wave will set up like this, and such wave is known as what? Transverse wave. Similarly, when you throw a stone in a quiet pond of water, for example, it's a pond of water, there's a water in it, for example, and you throw stone in it. What happens? Suppose a stone is thrown here, so we see that circular ripples are obtained, and those ripples they propagate to the edges or to the sides. Those ripples they are like this. They are also transverse waves like this. So those waves are called what? Transverse waves. Light waves also travel in this mode. They travel like this. Normally when we are describing light waves, basically what we do, we show an arrow like this. This is known as ray. The ray is just an arrow which shows the direction of propagation of light waves. It means that light waves are traveling in this direction, but basically light waves are transverse waves that travel in the form of this up and down part. Later on we will define that this up part is called crest and the down part is known as trough. So such waves which travel in the form of crest and trough, they are also known as transverse waves. So you need to define it and give a few examples. Next is longitudinal waves. These are the types of waves in which particles of the medium vibrate parallel to the wave motion. They are called what? Longitudinal waves. In case of transverse waves, you are moving your hand up and down. In this example, in the root waves, when you are moving your hand up and down, you can consider your hand as particle of the medium. You just move it up and down, and what happens as a result? Waves are set up in the loop, and in the loop each particle it moves up and down. The particles of the loop, they are not going in this direction, only the energy is traveled from your hand to the wall or to the hook. So this is the direction of traveling of energy, and this is the direction of the motion of your hand. So you can consider the motion of your hand as particles of the medium. They move up and down while the energy travels in this direction. And look at the angle here is how much? That is 90 degree. So we say that the word perpendicular, that the particles of the medium, they move perpendicular to the wave motion. But here in case of longitudinal waves, the particles of the medium, they move left and right, while the wave also travel in the direction of the particles of the medium. So this is the direction of motion of the particles of the medium, and this is the direction of waves. For example, sound waves. In case of sound waves, when we speak, our sound emits from our mouth in the form of successive compression. What is meant by compression? We will define it in sound chapter, but compression is the region of high pressure. When we speak, we give energy to the layers of air, and due to which the layers of air, they are compressed, and then those layers, they relax themselves and they transfer the energy to the next layers, so they are relaxed, and then the next layers, they are compressed. So sound waves travel in the form of successive compression and rarefaction. Compression is the region of high pressure, while rarefaction is the region of low pressure. So these gaps, when they are widened, it is known as rarefaction, and this is known as compression. This is rarefaction, and this is also compression. So sound waves travel in the form of compression, rarefaction, and so on. So this process, it occurs in this direction, and the sound also travels in this direction. So there is an angle of 0 degree between this arrow and this arrow. That is why we say that the type of waves in which particles of the medium vibrate parallel to the wave motion. So in this case, both the arrows are parallel, while in previous case this was up and down, and the energy was traveling in this direction. So here in sound waves, this is the particle of the medium, it moves up and down. Particle of the medium, it moves up and down, and this is the direction of energy or direction of waves. While in this case, this is the motion of the particle of the medium, and this is the direction of propagation of waves. So they are in the same direction, while here they are perpendicular to each other. When they are perpendicular, they are called transverse. When they are parallel, they are called longitudinal waves. So sound waves are longitudinal waves, while water waves, light waves, they are transverse waves. Next is another types of waves, and this type of waves or types of waves, they are on the basis of the requirement of the medium for waves. That is, there are two types of waves. One type of waves, they are called mechanical waves. These are the type of waves which require a material medium for their propagation. They are called mechanical. For example, sound waves. For sound waves, we need medium. Medium can be air, like gas. It can be solid, like iron. It can be liquid, like water. So on Earth, we have atmosphere, and this atmosphere consists of, that mixture of gases. And these mixture of gases, they are medium for transmission of sound. So sound waves require medium. If we are standing on moon, to talk to each other, we can't, because on moon there is no medium, there is no atmosphere. That is why sound waves cannot travel through space. Suppose that we are standing in a spacecraft, and suppose here we are, and here is moon, for example, and suppose there is a big meteoroid and it hits the surface of moon. We will be able to see spark created here. We will see spark, but we will not hear any sound. Why we see spark? Because light waves are created because of the collision. What happens? Because of the friction and the heat, energy is produced, that is light. And the light wave we can see here with our eyes, because light requires no medium. They are called electromagnetic waves. But sound requires medium, and the sound cannot travel in space. We cannot hear sound here. So sound waves cannot be heard in space, while light waves can be seen. It means sound waves require medium, while light waves, they do not require any medium. The type of waves which requires medium for their propagation, they are called what? Mechanical waves. Sound waves are mechanical waves. Definitely, if you want to create water waves, you need water for it. If there is no water, you cannot create water waves. Similarly, electromagnetic waves, these are the type of waves which require no material medium for their traveling or propagation. Light waves, microwaves, radio waves, they are all electromagnetic. They can travel through space as well. Next is progressive waves. Progressive waves, these are the type of waves which travel from source in all directions without having other boundaries. Suppose that when you are speaking or when you are shouting, your mouth is your source, and when you shout, the energy travels in different direction. We do not consider the boundary of our sound waves. So they are progressive waves. You throw a stone in a river, so the energy propagates in different direction. We call it progressive waves. So light waves, microwaves, and radio waves, they are also progressive waves. Light comes from sun and it's spread in universe, so they are what? They are progressive. They propagate in different direction. As compared to progressive waves, there is another type of waves which is known as stationary waves. From the name, it appears that these are types of waves which are confined, which are like standing in a region. They are called stationary waves. For example, waves produced in a straight string of a sitar or guitar. So suppose that here is one clamp, and here is another clamp, and there is a stretch string, and you pluck the string from the middle, for example. What happens? You see a loop is obtained in it, and when you release it, you see this structure, and this structure resides here between these two clamps. It moves up and down and resides here. Such waves which are produced in the string of sitar or guitar or stretch string, they are called stationary waves. They are confined in this region. That is why they are called stationary or standing waves. Okay, what you do, you study book with these types of waves. For today, it was just an introduction. So this is enough for today. Only you see the definition of waves in your book and the types of waves. You see the nice pictures in your books as well. study those those pictures as well with the definition of waves. Thanks. Now tasks of the day are: number 1, produce water waves in water. What you are going to do: take a container, put some water in it, and move a pouring pin or stick in it up and down with uniform speed. If you are doing this, this will give you periodic motion of your pen. Waves will be produced in it. Repeat the experiment and make video of it with mobile camera. Email or send the video to me on WhatsApp. Try to make a video not more than 15 MB. To ensure this, you need to be quick. The second task is produce waves in rope. What you are going to do: take a rope and fasten one of its end with the wall or window. Hold the other end and wiggle it. Move it periodically. Waves will be set up. What you are going to do again: take camera and make a video of it. Send it to me. Thanks a lot.